Graphing linear equations from a table. A linear graph represents all the pairs of numbers that make an equation in two variables true. Start with the equation, pick a value for x, input that value into the equation to find the value for y, then graph that point. In example 1, we have y equals x. You can use any numbers for x, but we will use -1, 0, and 1. Replace x with the value -1. This gives us y equals -1. Our first point then is -1, -1. Graph this point. Replace x with 0 for y equals 0. Our second point then is 0, 0. Graph this point. Replace x with 1 for y equals 1. Our third point then is 1, 1. Graph this point. Use a ruler to connect these dots. The points on this line represent all the places where y equals x. Every point on this line is a point where the y and the x are the same. In example 2, we will also use the values -1, 0, and 1 to fill in our equation. Be careful to include the negative when you rewrite the equation. Y equals negative. Now plug in -1. This gives us y equals +1. Our first point then is -1, +1. Graph this point. Our second point, plug in 0 for y equals -0 or y equals 0. Our second point then is 0, 0. Finally, our third point, we plug in 1 for y equals -1. This gives us a point 1, -1. Graph this point. Use a ruler to graph this line. This line represents all the points for which y equals -x. Example 3. Y equals 4x. Replace x with -1 for y equals 4 times -1, or y equals -4. Our first point then is -1, -4. Graph this point. Pause the video and finish this example yourself. Now that you have tried it, check your work. Replace x with 0 for y equals 4 times 0 or y equals 0. This point then is 0, 0. Graph this point. Replace x with 1 for 4 times 1 or 4. The third point then is 1, 4. Graph this point. Use a ruler to draw this line. This line represents all the points for which y equals 4 times x. Example 4. Y equals -4 times x. Start by replacing x with -1. This gives us y equals -4 times -1, or y equals +4. Our first point then is -1, 4. Graph this point. Pause the video and finish this example yourself. Now that you have tried it, check your work. Replace x with 0 for y equals -4 times 0 or 0. Our second point is 0, 0. Graph this point. Replace x with 1 for y equals -4 times 1 or y equals -4. Our third point is 1, -4. Graph this point. Use a ruler to draw the line. This line represents all the points for which y equals -4 times x. Example 5. Y equals 1/4 times x. This is the first time we're going to use different numbers for x. Instead of -1, 0, and 1, we're going to choose -4, 0, and 4. The reason is we're going to choose the denominator of the fraction that's the coefficient of x. We do this because when we multiply the fraction times its denominator, we will get a whole number answer, thus giving us an easier point to graph. Start by replacing x with -4. This gives us 1/4 times -4, or -1. Our first point then is -4, -1. Graph this point. Now replace x with 0 for y equals 1/4 times 0, which equals 0. Our second point is 0, 0. Graph this point. Now replace x with 4 for y equals 1/4 times 4, or y equals 1. Our third point is 4, 1. Graph this point. Use a ruler to draw this line. This line represents all the points for which y equals 1/4 of x. Example 6. Y equals -1/4 times x. Once again, we use the denominators to replace x. For y equals -1/4 times -4. This gives us y equals +1. Our first point then is -4, +1. Graph this point. Now replace x with 0 for y equals -1/4 times 0, or 0. So our second point is 0, 0. Now replace x with 4 for y equals -1/4 times 4. This gives us y equals -1. Our third point is 4, -1. Graph this point. Use a ruler to graph this line. This line represents all the points for which y equals -1/4 times x. Pause the video and try the next two examples yourself. Now that you have tried it, check your work. Example 7. Y equals 2/3 times x. Replace x with -3 for y equals 2/3 times -3. This gives us y equals -2. The first point then is -3, -2. Graph this point. Now replace x with 0 for y equals 2/3 times 0. This equals 0, so our second point is 0, 0. Now replace x with 3 for 2/3 times 3. Y equals 2. Our third point is 3, 2. Graph this point. Use a ruler to graph this line. This line represents all the points for which y equals 2/3 of x. Example 8. Y equals -2/3 times x. Replace x with -3 for y equals -2/3 times -3. This gives us a +2. Our first point then is -3, +2. Graph this point. Now replace x with 0. This gives us y equals -2/3 times 0, or 0. Our second point is 0, 0. Now replace x with 3 for -2/3 times 3, or -2. Our third point is 3, -2. Use a ruler to draw a line through these 3 points. This line represents all the points for which y equals -2/3 times x. Example 9. Y equals 2/3 x minus 4. Once again, we will use the denominator of the coefficient of x for our x values. So substitute -3 for x. We get 2/3 times -3 is -2. Now subtract 4 for -6. Our first point then is -3, -6. Graph this point. Now substitute 0 for x, giving us y equals 2/3 times 0 minus 4. This gives us 0 minus 4, or -4. Our second point is 0, -4. Graph this point. Finally, substitute 3 for x, for y equals 2/3 times 3 minus 4. This gives us 2 minus 4, or -2. Our last point is 3, -2. Graph this point. Use a ruler to draw a line through these 3 points. This line represents all the points for which y equals 2/3 of x minus 4. Pause the video and try the next example yourself. Now that you have tried it, check your work. Start by replacing x with -3 for -2/3 times -3 plus 4. This gives us a +2 plus 4 for 6. Our first point then is -3, 6. Graph this point. Now replace x with 0 for y equals negative 2/3 times 0 plus 4. This gives us 0 plus 4, or 4. Our second point is 0, 4. Graph this point. Now replace x with 3 for y equals negative 2/3 times 3 plus 4. This gives us negative 2 plus 4, or 2. Our third point is 3, 2. Use a ruler to draw a line through these 3 points. This line represents all of the points for which y equals negative 2/3 times x plus 4. Now pause the video and try the next example yourself. Now that you have tried it, check your work. In this case, we do not have a fraction coefficient of x, so we go back to using negative 1, 0, and 1 for our x's. Replace x with negative 1 for y equals 4 times negative 1 plus 2, or negative 4 plus 2. Our first point then is negative 1, negative 2. Now replace x with 0 for y equals 4 times 0 plus 2, or 0 plus 2. This gives us 0, 2 for our second point. Now replace x with 1 for 4 times 1 plus 2, or 4 plus 2. This gives us 1, 6 for our third point. Connect the 3 dots by drawing a line through all of them. This line represents all the points for which y equals 4x plus 2. Pause the video and try the next example yourself. Now that you have tried it, check your work. Substitute negative 1 for x. This gives us y equals negative 4 times negative 1 minus 5, or positive 4 minus 5. Our first point is negative 1, negative 1. Now substitute 0 for x. This gives us negative 4 times 0 minus 5, or 0 minus 5. Our second point is 0, negative 5. Now substitute 1 for x. This gives us negative 4 times 1 minus 5, or negative 4 minus 5. Our third point is 1, negative 9. This point is off the grid, somewhere down here. Nonetheless, we can connect the dots we already have to make our line. This line represents all the points for which y equals negative 4x minus 5. The last 2 examples are special cases. Notice that in number 13 there is no x. There is only y equals negative 5. This means we know that y is always negative 5. You can fill in negative 5 for every different x. That means our first point is negative 1, negative 5. Our second point is 0, negative 5. And our third point is 1, negative 5. Take a ruler and draw a line through these 3 points. Notice that this line is horizontal through y equals negative 5. Whenever you have a line which has a y equals a number and no x in the equation, you get a horizontal line through that number. Example 14 is also a special case. In this case, we have x equals 3 with no y showing up. So we put 3 under all the x's and we fill in the y's with different numbers. This gives us 3, negative 1, 3, 0, and 3, 1. Use a ruler to draw a line through these 3 points. Notice that this is a vertical line. Anytime we have an equation that includes only x and no y, we will get a vertical line. When we have x equals a number, we'll get a vertical line through that number. Please refer back to these notes often as you complete your homework. Thank you.